hit the recording.
All right, thanks, Min. So my name is Matt Kelly. I work for the Boeing company, and I'm the Tools Working Group lead. So we'll just jump right in. So at a high level, what is the Tools Working Group? So the working group's mission statement is, the Tool Investigation and Code Improvement Working Group focuses on the creation, analysis, and application of tools and techniques to contribute to the improvement of the kernel for use in safety cases. And we'll talk a little bit about that mission statement and the history of it in the next slide. But the primary thing here is we focus on tooling around the kernel. So you heard Philip mention some of those tools. We also have a member, Sudeep, who maintains the CI setups that the ELISA working groups have. And the kind of the original mission statement of the working group was more focused on static analysis. And we do still talk about static analysis issues in the kernel. So what did we do in 2024? We had 22 unique attendees across 17 different meetings. Those were great improvement, a great improvement in attendance from, I think, the end of last year when I first took over the working group. I've been in charge of it for like a year and change. I think it was maybe like last October. And we would have about one other person show up, and just trying to find the right direction for the working group. Part of what we did this year was broaden the working group's mission statement. So previously the working group was really focused on static analysis and how it applied to the kernel and submitting patches. And as the previous working group lead, Lucas would always say, like, we kind of completed our mission, which is to train people up on how to submit patches for static analysis issues against the kernel. And once you've trained people how to do that, they don't really need to come back to the working group. And so we tried to change the angle a little bit to, hey, this working group is going to support the different tools that support the efforts that we have going on in the various groups. So in that vein, we pulled in 4 different tools under this umbrella. So you heard Philip mention KSNav. We'll talk about all these in a little bit more detail in a minute. But KSNav, Bazel, Delta Kernel, and LLVM Cov, those all originated in different working groups or at one of the participant companies, and now they're kind of the core focus of this group. So some interesting accomplishments that we had first cross-company contribution. That was to KSNav. Bazel had our first known outside users of a working group tool. So Luigi mentioned that some people are submitting issues against the Bazel repo, and he was not aware who they were. That's a great thing. The other things I'd like to mention, we did engage with some outside groups on relevant collaboration. So Craigit is a kind of a kernel history authoring tool where you can see who committed to what lines, or actually what tokens, in great detail. It has a lot of overlap with Delta kernel, which we'll talk about in a minute. And then StressNG is really a stress testing suite, but it kind of gets to testing the kernel and how we tie lifecycle artifacts together. And so we talked to Colin King, who's the kind of principal developer over that. I did also want to say we do still welcome discussion on kernel static analysis results and patching. We had at least one member who used the knowledge in the group to upstream a kernel contribution this year. And so that activity is not totally lost, though it has kind of taken a backseat to some of the other things that we're doing. So I'll just jump into KSNav. So KSNav is the kernel kernel source navigator is kind of what it's short for. Alessandro from Red Hat's kind of the primary developer here. He's also leading the Linux features working group, so you'll hear from him later. So what is it at a really high level? It's a kernel binary analysis tool to assist with ISO 26262 freedom of interference analysis. I'm an aerospace guy, so I'm not going to deep dive you on what FFI analysis is because I don't know. But you can get it here. The main thrust of it is that you can look at a system call, pick a particular system call, and based on the binary, we'll analyze what parts of the system actually interact with that system call. So you'll see things branch out in really interesting ways from a system call into other parts of the kernel, and give you an idea of what you're dependent on when you make one simple system call. So some of the improvements that were made in 2024, big improvements to the web interface. Another improvement that Alessandro added was a way to track global variables. So you can actually pick global variables out of the kernel and see exactly where they're accessed, which is really neat and potentially useful for safety analysis. right? Because global variables are generally frowned upon in our safety code. However, we can't get away from them in the kernel. Another more recent improvement was integrating some ftrace-based coverage analysis. This was a realization that came from a realization that kind of statement-based coverage is not always exactly what you need. And so the picture you're seeing over here is kind of an example of that. It does ftrace-based coverage analysis based on the functions that are called from a particular root function. And so it's kind of a different take on how to do coverage analysis. The big plan from 2025 is to continue working on what Alessandro calls the indirect function call problem. This is basically anywhere you hit a function pointer, you have a lot of different options from where that function, where that call tree could actually go. And so trying to get a clearer picture of how that particular problem actually plays out in the kernel and how we can add more detail to the analysis there. Moving on, Bazel. So Bazel is another tool from Red Hat. Luigi is the primary developer. More or less, it's a lifecycle artifact traceability tooling. So it allows you to load in different things like requirements, test cases, test procedures, test results, and tie them all together in a meaningful way. I won't go into detail because there's just a lot of features in this tool, but you can both get it out on GitHub, and we actually have a live instance of it where you can try it. So you can create a new user and kind of poke around. There's some sample data loaded in there that will help get you an idea of what's going on. So what did we do in 2024? A big thing was actually getting a public instance for people to experiment with. So I hope you go out and try that. And then there was various issues added for linking test cases to requirement specs and triggering tests in external CI systems. So if you have a GitLab or GitHub CI system, you can actually trigger a test based on data in Bazel. And there's lots of talks out there that Luigi has given about this tool. It's way too much to get into in a short time period, but just giving you a high level idea of what's going on here. Some of the plans for 2025, so SPDX 3.0 integration. To me, this is one of the really important things in an open group like this, is that we have a data exchange format that we can all talk to. SPDX is a good example here. Where the tool can import and export SPDX format. And so that gives us a way to have different tools, but have a common way to talk across those tools. And then also SBOM integration. So SBOM is blowing up in the industry in terms of embedded, in terms of tracking exactly what goes into your product. And so Luigi Sense is doing some work with integrating SBOMs into Bazel as well. Delta kernel, this is a tool that came from a Boeing effort. So one of the big things in the aerospace realm is what we call software change impact analysis. So if you're going to upgrade a kernel or if you're going to upgrade a piece of software, how does that affect the system? And so one of the tools we started working on was comparing different versions of the kernel. So you can actually see in this little snip, if that's readable for you guys, this is comparing 5.15 with 5.15.100 and just giving you a visual report of the change between those two kernel versions. At this point, this is a pretty basic tool, but we did the initial release of this tooling this year. It's super useful for us. We don't have anybody actively working on this at the moment in 2025, but we do have ideas of how we would like to extend it. In particular, comparing kernel configurations. So easily identifying, new configurations that came in or changes to the default configurations that are out there. We happily welcome contributions here. This one has a pretty low barrier to contribution because it's basically just a Python script. And so we welcome people jumping in to make this tool better. It's kind of a variant of Cregit, as I mentioned earlier. Cregit is more focused on tokens and who authored that token. This is more focused on differences between versions of the kernel. And then the last major effort is some effort around LLVM-Cov. So this particular effort is a joint effort between Boeing and the University of Illinois at Urbana-Champaign, where we're enhancing LLVM-Cov to do MCDC coverage and object code coverage. So the aerospace realm at software level A requires that you do MCDC level coverage, and what we identified is that there's no open source tools that can actually do that. And so we partnered with UIUC to add that capability into an open source tool. What we found is that there was actually somebody already working on this from Texas Instruments. I think his name is Alan Phipps, adding that to LLVM. And so we leveraged that work and made sure that it worked against the kernel. We did actually have to submit some fixes to both the LLVM implementation and also the kernel to get this working. But if you go grab LLVM 19.1 or later, this the MCDC coverage is in there. You can see an example of the report here, showing exactly what the output looks like if you run into a multi-conditional if statement, and it details exactly which pairs are covered and which pairs are not covered. And then object code coverage is currently in work with this group. After some design, implementation discussion, it's actually been decided this will be a different tool, so it will not actually be baked into LLVM Cov, but it'll be an open source tool released under LLVM that allows us to look at object code coverage, so looking at the assembly in which if there's any paths in the assembly that don't match paths that are directly in the source code. So 2024 updates. This project has actually been in work for at least starting in 2023. I forget the exact date, but we did a demo of this MCDC coverage of the kernel at Linux Plumbers, which generated some really interesting conversation, including some interest in collaboration with kernel CI to get these MCDC coverage numbers from LLVM pumping out of kernel CI so that developers actually have that data. And then we've also started a DO330 qualification effort that will be open source, at least to some degree as well. That effort, DO330 is kind of the tool qualification. So in order to show that a tool works in the aerospace industry, you have to follow DO330, which is kind of roughly equivalent to I have requirements and I wrote tests. I'm oversimplifying it there because I'm not a tool qualification expert, but that's the main gist of it. Okay, and then kind of laying out a vision for 2025. So 2024, I think, was a year where we experienced a big shift in the working group's mission statement and just trying to gather, useful decisions and conversations around the tools that we have. And in 2025, I think we're trying to take the next step into creating something more useful than the individual parts that we've pulled into this umbrella. And so in the last couple of meetings, we've talked about, how can we present a use case which connects the different tools and efforts that we're working on in this working group to create something greater. So I've kind of drawn the most basic of diagrams over here that show how that might be possible, how we'll leverage the existing tools that we have to create something more interesting. So how does this work? So KSNav gives us call trees that help us understand the parts of our system, and we're hoping that'll inform requirements understanding. And one of the other efforts that's outside of this working group, I think it's sitting under the systems architecture working group. So you might hear about this in one of the other talks today, is there's an effort going on around kernel documentation and kind of low-level requirements, I'll call them. And there's a decent amount of momentum there. So the idea is we'll kind of use KSNav to help us understand the requirements. We'll actually create a requirement in the ftrace area of the kernel against an existing test. And then we'll set up a CI which loads data from the kernel. So I guess I skipped over one important thing. With that kernel requirements effort, one of the key pieces that came out of, I can't remember if it was Plumbers or one of the other conferences, is that some of the key people in these areas have agreed that we should put these requirements directly in the kernel source. And so that leads us to the next point, where we'll create a CI that actually is running over the actual live kernel data and pulling in our lifecycle elements. So pulling in the requirements, pulling in the tests into Bazel, which ties all those elements together. And then we'll use Bazel to trigger test runs in kernel CI, which generate LLVM coverage data. And so now we're starting to link these tools together in a way that creates something that looks like software change impact analysis. So if we have all that data linked together in Bazel, and we're using the requirement to generate a test case to generate coverage, we can actually see how changes then impact the downstream results. So what happens if we change the source code in the middle? Do we still assess that we have accurate requirements coverage? That's one of the things that Basil allows us to do. If we change a test, does that mean our coverage has gone down, or does that mean our coverage is now complete? And so we're really hoping that this can, demonstrate, a greater impact through the combination of the tools that we've pulled together here. All right, so how can you guys get involved? We have meetings on the 2nd. I don't know what happened there. 2nd, Tuesday of the month, and the 4th Thursday of the month. You can hit our GitHub, which has all this information. You can hit the mailing list. I've also provided a bunch of links to the different tools that we're supporting. And I'll stop there and let people ask questions if they have any.
If you want to speak, you can also raise your hand and I'll unmute you.
I know that's a whirlwind tour of a lot of disconnected parts, so I've stunned the audience into silence.
Now there's a question in the chat. And the question is if you can use these tools for other software, which is a very good question.
Yeah, good question. Some of them are, it depends is what I would say. So some of them are fit to the kernel in particular. That doesn't mean they couldn't be extended to more generic use cases. So KSNav, for instance, is pretty focused on the kernel. The method that it uses is not specific to the kernel, and so it could be extended, but probably would need some work. Bazel is generic, I would say. You could use it on any piece of software that includes or doesn't include the kernel. Delta kernel is pretty fit to the kernel at this point in time. And then LLVM Cov, no, it's not fit to the kernel at all. But one of the key efforts that Boeing undertook with UIUC was to make sure that it worked on the kernel, which did require some kernel patches and other things like that. So yeah, that work is completely generic. So yeah, just kind of depends on which part you're looking at.
And I would add, of course, as we are in safety critical space, we designed it for safety critical parts, but the use cases can be much wider, of course. For example, the workload tracing thing, which we did in medical, which is also some kind of tool or description, applies to any kind of use case. And I also heard that other industries, for example, have been interested in using Bazel for their requirements tracking or expectation tracking in their standard industrial projects they are working with, so that you can really see the tools fit into many different use cases, but to the Linux ecosystem.
Kind of along those lines, we've seen some cool knock-on effects of doing this work. So for instance, the LLVM Cov work, it hit LLVM, and then we saw some people picked it up and started talking about adding MCDC coverage to REST. And we were not involved with them. We just noticed that activity started happening. So you do good things in the open and other people start following or participating in what you're doing. And that's been really neat to see. So we're hoping we can multiply that effect with the work that the working group is doing here.
There's one more question.
Yeah, no, Bazel doesn't produce the SBOMs, but Bazel would ingest the SBOMs to link lifecycle data together. So SBOMs would be considered a piece of lifecycle data that goes into what you're doing there. Yeah, I'm sorry I couldn't cover Bazel in more detail. You could spend an hour or more talking about what Bazel does. I highly encourage you to just go jump in the instance and start poking around. And reach out to us or join the working group, and we can get you more information.
And we also have a seminar around this where Luigi explains
the
basics of it
videos.
and then play around it, as you say, Matt. Yeah.
Yeah, there's videos on at least the LLVM cov work, Bazel, and KSNav. I don't think we have a presentation on Delta kernel, but you can go poke around that yourself. It's fairly straightforward.
Great. Thank you, Matt.
Thanks.
I'll